Here are solutions to homework set number 2 for ECE 111. In this homework set, we're looking at solving problems that you'll encounter in Math 103 Algebra, specifically how to find the function equals 0. Now the first problem is I've got a function y equals x log of x. If y is 5, solve for x. If y is 10, solve for x. Now there's a couple ways of doing this. This is a problem you really can't solve with a closed form solution. What you can do is graph it. So for example, over in Matlab, where's Matlab? In Matlab, I can sit there and say, let's guess x is somewhere between 0.1 and 8. Say 10. Y is x log of x. And in Matlab, I've used the dot notation. That tells Matlab this is an element by element multiply. Matlab is actually a matrix language. If I plot x versus y, and then turn on the grid lines, the solution I'm looking for when y is equal to 5, here's x, it's about 3.4. When y is equal to 10, solve for x, about 5.6-ish. That's a graphical solution. Can I solve using numerical methods and get more resolution? So to start with, what I'm going to do is come up with a function. I'm going to guess x is going to return the error. So here's y is x log of x. Return y minus 5. Find y such that the error is 0. Now using Newton's method, what I do is I just take a guess. Let's just guess that x is equal to 3. Then I'm going to iterate. Iterate 10 times. So what it does is it first solves, given your guess 3, find the error, perturb it just a hair. Find the error. Now draw the tangent. So back over here, when I start out with 3, I'm going to find out when it's equal to 5. I'm going to sit there and draw the tangent line to it and see where it hits 5. Or in this case, where the error is 0, since I subtract 5. That's what this calculation does. It'll be a little bit wrong because there's some bend to it. Now iterate 10 times. And what that does is if my first guess is 3, my error is I'm off by 1.7. Draw the tangent and see where it hits. Next guess is 3.81. I'm off by 0.1, 3.78, 0.00025. Fourth guess, fifth guess. And after 10 iterations, I'm dead on. That's Newton's method. Newton's method, well, pretty much any rule of thumb. Anytime you see an algorithm with the name Newton or Gauss, it's usually a really good method. So here Newton's method converged and only took like 3 or 4 guesses. Let's try again. If y is equal to 10, I change my cost function, or my function. Calculate y is x log of x, subtract 10, and that's how much I'm off. Now repeat. What's going to happen is over here, my first guess is 3. I want to find out when it's equal to 10, or when y minus 10 is equal to 0. Draw the tangent, see where it hits 10. That's my first guess. Now draw the tangent, see where it hits 10. Keep on iterating. So now, my first guess is 3. I'm off by 6.7. My next guess is, draw the tangent, 6.19. I'm a little bit high. 5.73, and you can see very quickly I converge. The answer is actually 5.72892556538691. Or a little bit more accurate than I can read the graph. That's the beauty of Newton's method. I can solve pretty much any function equals 0. Even though y is x log of x has no closed form solution, a numerical solution can be found. And Newton's method converges really, really fast. This is a technique that I actually use quite often. Newton's method is very fast, very quick, very easy to use. And if you ever watch the movie Hidden Numbers, and they talk about Newton's method, gee, that's really, really old. Well, this is Newton's method. Problem 2. Let x and y, well, solve 2 equations, 2 unknowns. Y is cosine 3x, and also y is x plus 1 times x minus 2. Solve using Newton's method. Well, one way to solve is using graphical methods. I'm going to guess x is somewhere between -4 and +4. That's just a guess. call this one y1, call this one y2, and plot the two on the same graph. Where they intersect, right here and right there, are your solutions. So this is a graphical solution. Repeat using Newton's method. So again, what I'm going to do is come up with a function, I guess x, and it tells you the error, the distance between the two. So like if this is my guess, minus 2, it's going to return this distance. If this is my guess, the distance is 0. That's what I want to find. Function equals 0. So here's my function. I guess x calculates y1, calculates y2, and returns, this guy's what gets returned, the difference in the two. I can now repeat using Newton's method just like before. I'm going to take my first guess, analyze it, perturb it just a hair. Now from those two, draw the tangent and see where it intersects the x-axis, and repeat. So my first guess is minus 1. There's the error. It then iterates and finds the solution, and very quickly finds the solution, is minus 0.76233. So this is the solution right here, minus 0.76233. To find the solution over here, take a guess that's close to that answer, like plus 2. If I try plus 2, there's my first guess. It then draws the tangent, iterates, and the solution it finds is 2.2663489907174. Lots of decimal places. So I can find two solutions. Now, a problem with Newton's method is you kind of have to know the answer to find the answer. But the nice thing about it is if I want to find the answer close to minus 0.6, make that your first guess. Find an answer close to over here, make this my first guess, and it's going to usually converge to the solution close to your guess. Problem 4. Suppose I have a thermistor. This is the temperature versus resistance. Write a Matlab function where I pass the temperature T and returns the error between the actual resistance and what I want it to be. So suppose I want to find out the temperature is 5,000, the resistance is 5,000 ohms. What's the temperature? I'm going to guess T. Given T, calculate the resistance, that's this equation, converted to Matlab, then return the difference. Once I have that, I can use Newton's method, same as we did before, just call a different function, and find out what is the resistance at 5,000 ohms and 10,000 ohms. So when I make R0 5,000, I make my first guess, 2 degrees Celsius, there's my error in ohms. It then iterates using Newton's method and pretty quickly winds up at 5,000 ohms. The temperature is 6.80878868 degrees Celsius. If I make this 10,000 ohms, use Newton's method, same as before, it converges to minus 5.54195 degrees Celsius. So this is one way to solve one equation, one unknowns, using numerical methods, like Newton's method. I can do more complicated problems, such as if I have temperature causes the resistance to change. If I have a voltage divider, the resistance causes the voltage to change. If I know the voltage, what's the temperature? Well, here what I'm going to do is if the voltage is 8, I'm going to guess the temperature. Once I know the temperature, I know the resistance. Once I know the resistance, I know the voltage. Return the difference between the voltage and what it's supposed to be. Now I can use Newton's method. Its function equals 0. What temperature causes the error to be 0? So if I measure 8 volts, make that 8. Use Newton's method. So everything stays the same. I just change which routine I'm calling. If my first guess is 2 degrees Celsius, I'm off by 1.8 volts. Keep on iterating, and at minus 13.314363747748988 degrees Celsius, I'm at 8 volts. The error is 0. And that's actually how a thermometer works. Electronic thermometer. I use a thermistor that converts temperature to resistance is the voltage divider that converts resistance to voltage. If I know the voltage, I know the temperature. In this case, 8 volts is minus 13 degrees Celsius. If I'm at 6 volts, iterating, I'm at 3.45 degrees Celsius. So that is homework set number 2 for ECE 111. And kind of note, Matlab is really, really useful. Using numerical methods, I can solve one equation, one unknown. Same thing you're going to do in Math 103 Algebra, where you solve one equation, one unknown. In algebra, you do manipulation to try to solve. Using numerical methods, I can check my answer. If I solve these equations to find temperature given voltage, I should get 3.45088 degrees Celsius. The two answers should match up. Numerical methods are nice because they can pretty much solve any problem. Algebra is nice because I don't have to go through these computations to find it, but you should get the same answer. That's homework set number 2 for ECE 111.